Hello, my name is Gustavo Bez, and this is an introductory video on Motion Tools 1.0. And Motion Tools is just a little set of tools to help you work with motion graphics inside of Softimage. It basically has some scripts and compounds that will make it easier for you to do both procedurally and simulated animation of many instances or many objects. And right here we have an example that was shown at the beginning of this video, and this was completely done with this nodes right here. And you have the basic anatomy of one of these trees is you have a point creation process in here. Then we set the shape and color of these points, and in this case we're instancing this grid object right here. And then we have a bunch of modifiers that we can apply in a specific order. In this case we have a null that hovers one of these points, and whenever it does so the instance goes into the camera. So the idea with motion tools was to abstract many of the complications in ICE for beginners, and we always encourage you to use the ICEtree anyways, because it's a very simple structure that it's built right here. But we also have many menus that can help you start from scratch. So let's begin a scene from scratch and see how this works. So the first thing you want to do is build the points from scratch, and in here we have three different ways of creating these points in space. The first one would be very geometric, and the second one would be to build these points based on a object, and the third one would be to create points based on polygon islands of a object. So let's start with the first one. And we have three methods right here. So I start with linear, and I'll just right now I could instance some objects if I wanted to. Right now I don't have any objects to instance, so I'll just right click and I'll get the basic shape, which is a cube. And I'll just put this to the side right here, and right now we can see there's a cube distribution here, a linear distribution of cubes in here, and we can change the repetitions. And since a line has only one dimension, we can't change this in here. But if we would choose a grid, for example, we then could change all three dimensions. And as you can see, this is pretty fast. Doesn't matter how many instances you throw at them, it's it's amazing at speed. And right here we also have radial distribution, and we can also play with the controls right here, and there's all these different parameters you can mess up with to get the effect you want, and you can already start playing with some motion in here. So this is very flexible to get many abstract shapes that are used in motion graphics. There's also a step mode right here. As you saw, I was controlling the end point and the starting point of this effect, and I could also just control a step like so, and then I can grow or shrink this effect when I change the repetition. If I have step mode off, I'll just increase or decrease repetitions in between these 2 points. So that's it for geometric distributions. Now we could also have distributions based on a volume, so we could get a model right here like a T-Rex. I'm just gonna make this wireframe so we can see better. And we could create instances on this geometry, and we could do, for example, at the vertices of the geometry, and now here it tells me I got to pick the object to instance on. So I'll just pick this one, and I'll right click, and now it will create a cube at every point of my geometry. I could change the mode again to edges or to polygons, and you see that when I change to edge or polygons, it does the smart thing of scaling according to the element scale. It won't do that to the vertex because the vertex has no scale, and you can control that with this property right here. Then we could place these on the surface or also inside the volume, like randomly, like so. And then we could change the resolution, or we could place this like on a voxel grid, and also here we can change the resolution. So we can like voxelize this T-Rex, for example. So as you can see, still stuff runs pretty smooth. And what else? We could also, instead of just using cubes like I'm doing here, we can use instances. So for example, I could get a model, like I could get a ball and a, what else, a lizard, and instance the lizard on the polygons or on the edges of this ball. So I could then create instance at edges, select the ball, then select the lizard, and right click. Now I have the lizards placed on the ball. I could now align to geometry if I want to, and then they will be going the right direction. So every time I'm doing this, it's important to notice that I am creating an ICEtree, and it follows basically the same pattern we saw before. There is a root that is basically just there to tell you the basic structure of this stuff, and then there is this point creation. I can unplug it, and you see there's no points there anymore. If I plug it, I get them back. Then there is the shape and color, which will tell that it has to use the lizard, and it got to be that certain scale, and you gotta have that certain color. The color, actually, since we're instancing something, it will get the color from the actual object. But for example, if I was to unplug this, I would have just the basic shape of any particle in Softimage. And I plug this, and I get the shape I chose. And so then I could, like, for example, I could basically throw this away and go back to the right here we have in tests, we have motion tools, and then I have all the generators in here, and I could get that basic linear array back again. Right now I have a grid, I could have a linear, and now I have those lizards on a linear array right here. The last method for point creation in motion tools is to use chunks of geometry to define the position of the points, and I'll show you with this prefactored geometry right here. So I select it and create instance from polygon islands, and as soon as I do that, if I check the wireframe, points are created at the middle of this islands and these chunks of geometry, and I can control these points and with modifiers, like for example randomize. And right now I'm randomizing the size. I could randomize the position, and you see that these points move in space, and they actually are constrained, or actually the geometry is constrained to the points. So the ICEtree is similar to what we have seen before. So we have the points, the shape, the modifiers, and at the end we have a constraint that does this that generates this behavior. So I'll delete this and show another useful way to use this with text. You can, for example, create a regular Softimage text like this one, and we can then use them as input for our point cloud. And I just did the same thing I did with the prefactor object. As you can see, there is a point for each text right here. There is a point for each letter right here, and I can then apply modifiers to animate procedurally, animate this text procedurally, like so. On objects that don't have any chunks, like this sphere, for example, we can also use we can dice each polygon into an island and control those islands, like so. For now, you can see there is a little particle for each one of my polygons, and they have all been disconnected. If I then apply a modifier to this point cloud right here, like to be harmonic steps, I now control each one of the polygons in my object. Modifiers help us to change the look of our point cloud in a procedural way. Let's talk a little bit more in detail about them. So the two most basic modifiers are these ones, modify transform and modify color, and I'll just apply both of them like this one, and I'll apply a color. Okay, so as you can see, they just do very basic transformations. So this one changes any transform property in the object, and this other one just changes the color. And both of them have this blend parameter, and they also happen in a certain order, like this modification is working after this one. So all or most of the other modifiers are based on these guys right here, and some of them are just a combination of modifiers and modulators. So modulators are under this tab right here, and they're little light blue, and you can plug them into the blend. So for example, if I was to have scale right here, and I have a linear stepper right here, which just acts a little bit like a fall off, and it's in the U-axis, so in this case it matches the x-axis right here, and it's happening from 0 to 1. I could clamp this to affect just a little area, and it's outputting a value from 0 to 1, so I could change this from more or less, and I could also make it not linear. I could curve it like so. And I could, instead of applying this to the blend, I could apply to any of these green ports right here. So it's very powerful. You can make many combinations. For example, the modifier linear stepper, as we can see, is just a regular modified transform with a linear stepper connected to it. And I could, for example, change the translation like so, and I could also change the color like so. So other modifiers we have in here, we have harmonic steps, which makes like a sin function, and modify over time, which kind of like cumulates the effect over time, although it's not a simulation, it's procedural. We have modify with object, and we can connect some object. It could be a null or a mesh. In this case, a null, it's of course much faster, so I'm going to use a box and pick my null. Now I can do any kind of transformation whenever things are inside this box. What else we got? Point at. I can do the same thing. Point at this target right here, and all my instances will be looking at it. And randomize. Pretty straightforward. Randomize anything, translation, rotation. So the new one, and that I'll be showing, is get animation from clip. So what this one does, it gets a animation clip from your mixer and applies to all the instances. So we could animate this cube right here, for example. I'll just hide everything else for now and just use all my animator skills in the scene. I'll key it at the beginning. Just do some weird motion right here. It's like so, 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 so. Okay, that should be enough. Let's play to see it. Okay, it looks fine. Not the best thing in the world, but it will serve our purpose. So now I can store this under animation, store F curves. No, don't want to remove. And if I have my ICEtree back, I can now pick the animation I saved as a clip. And I also gotta tell it which object I used to store the animation, since a clip may have many objects in it. So I'll pick my null, and if I press play, now all my objects should have that animation. I could also use the modulators to offset this, so I could, for example, offset them in the v-axis and for like 10 or 20 frames. So already some cool motion right here. So a part of just procedurally animating everything, we're using ICE, so of course we can simulate stuff. And I'm going to use this text as an example. I'll just create points for each one of these chunks of geometry, and I'll then simulate them at all times. So I'll choose simulate always. I'll choose a collider if I want to, so I'll pick this ground, and you can see we're using right here a bullet to simulate this. I can control the precision, maybe change some properties on the collider. So as I press play, you can see stuff is correctly animated. I could also mix procedural animation with simulation. I'm gonna delete the simulation part of this point cloud, so I still want to keep the point generation and the constraint. I'm gonna throw it back in here, but I want to get rid of the simulation. Also get rid of this, and I'll now create a simulation that happens only when triggered. So it's basically the same thing, but what this means is that I need to do something in order to trigger the simulation. you see that right off the bat, nothing happens. So if I pick my point cloud right here and go into the ICEtree, let's just do it in a little bit more organized fashion. If I go into the ICEtree of the simulation, it's a bit more complicated. Right here in the first execution, I have a apply modifiers inside simulation. So right here I can input procedural animation, and it will happen just as if it were outside simulation. And then we are using the state machine inside the simulation root to kick the particles into simulation state once a triggered, which is this orange thing, is executed. So for example, if I just double click my simulation root and trigger my trigger, everything is now simulated at all times. But I can input a test condition in here, so it only happens for some particles. So in ICE we can, there are many tests we can do. We just need to type in test here to see all the ones. And I'll test inside null, for example. I'll plug this into my trigger, and I'll bring a null into my scene. So I can like create a null here that is a box, and I'll place it right here for now. So I want this null in here, and I want it connected to the test. As I press play, you see nothing happens until I hover the box over the text. If I give it some more frames, you can see it better. Just, activating, triggering this animation. And we can actually input some procedural animation beforehand. Like so. Collapse it all to just be a little bit more organized. So this is how it looks. Very simple stuff. And this is how it looks in motion. Well, I hope I could give you a little bit of intuition on the potentialities of the system, and I hope you enjoy using it.